Okay, so today we're going to go over some of these reactions and make sure that everybody's on the same page. These are reactions that are specific to the amines and the amides area that we just completed. So I'm going to cover these up just to hopefully it seems a little bit more straightforward, but I'm going to go through these with you. I also want you to try these and then check your answers. So when I show you this, pause the video for a second, see if you can do this, and come up with the same answer that I did. And when you check yourself through the video, then you can tell whether or not you were on the right page. And if not, I'll try to explain at the end where I come up with these things so that you can sort of understand what's going on. Okay, in this case we have a carboxylic acid and we have an amine. Using heat, we can make an amide bond. We also make water. Realize that it doesn't matter what is back here. This is just an R group. This is carbon stuff. I hope you all realize by now that this is what does matter. This is the functional group. This is the functional group. This is most definitely a methyl group that's coming off of that nitrogen. So the product here should be an amide. This does not change. This does not change. There is, however, a nitrogen there that's connected to a carbon. Nitrogen has 3 bonds. That means that the hydrogen is still there. Okay. You also get water from this. Keep in mind what's happening here is that this OH and one of these 2 hydrogen here are what makes that water. That means that this nitrogen would then only have 2 bonds, and the third one goes to that C double O bond. Now that is a simplification of what's actually happening on a chemical level, but that's a way to remember these. Okay? Good. Next question. I'm trying to keep these simple so that you don't get lost and confused here. So, pause the video and try it. This is an amide bond with a base and heat. The same way we can put an amide together, both base and acid separates carboxylic acid from amine if you start with an amide. So this other stuff still just there. I also get a COOH. I'm going to write that first. That's not really the answer. That's a placeholder for me right now, okay? So if we think of what it is that makes this amide, like the reverse of the last thing, that's what it would look like, right? Now let's take into account, so these 2 things together, if you were making that this way, that would make this, right? That's where I come up with these from. Now let's take into account the fact that this is in a base, and a strong base. And this starting material is known as carboxylic acid. Since it's in carboxylic acid, this hydrogen right here reacts with this OH right here and forms water. So I'm going to mark through that and say plus H2O. Now by removing that H off of the end, that's going to leave us with a carboxylate, so a negative charge. And that means that the Na, remember this is Na plus and OH minus, will kind of stick around with that O negative. Okay? So when you're solving these types of problems, the easiest way in my mind to do these is first figure out what it is that could have made that amide, and then figure out how the base reacts with those things after the fact. I'm going to do the same thing with acid in the next problem. Okay? So here's my next problem. There we go. Let's go ahead and pause it and try it. Okay. So when we're solving this again, I want this in acid and water and heat. And it doesn't matter if the acid and water is over here or over here, it's still acid and water. We are going to again make the carboxylic acid and the amine. Okay, let's start by doing that. Doesn't matter what this is, but that would be my carboxylic acid. The amine that you would use would be in boom, boom, boom. Now keep in mind there is an H that's here, whether it's drawn there or not. So there's the H that I have from right there. Just a moment and I'll get some more pens in here. Different colors. Makes life interesting. So I'm going to show you all where this H2O comes from, right? The OH went right here. The hydrogen from that water is going to go right there. Not come from, but go to right there. Okay. Oops, that color's too similar. Let me find something else. Here we go. Now, that's my carboxylic acid and my amine. Considering the fact that it is in acid, an acid reacts with a base. This is an acid. Remember that this is a weak base. What that means is this hydrogen that's right here is going to come over here. So this HCl right here, that's that hydrogen right there. Remember, when you have 4 bonds to nitrogen, that leaves it with a positive charge. In order to balance out that positive charge, it's an ionic bond now, you have to add a Cl over here. And these two form an ionic bond. Now keep in mind that this Cl came from this guy right here, that HCl. Okay? Good. Past this, I think we're pretty much practicing these 3 reactions. So definitely pause it and make sure that you try to do these yourself. Next one. This is actually just like the last one, a little bit different. A little bit different with what's actually connected everywhere, but it's really the same type of reaction, right? So I've got an NH, boom, 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 boom. Those are what I would start with my amine and my carboxylic acid. This H2O is accounted for here and here. So the HCl will be added here. That's my positive charge. Cl minus. And there we go. Okay. Next problem. Pause it and try. Okay. This is another amide, and we're going to use a base this time. So let's start with determining what that carboxylic acid was. There we go. And the amine would be simply NH3. Now, if you didn't know that, that's okay. You can draw this out. It's the same exact thing. So H, H. The third one comes from sorry, there is also water in here. Okay, my apologies. So this water is here, HOH, and one here as well. Okay. Now, because we're in a base, it's going to react with the acid. That means that this hydrogen will go away and form water. Okay. You get a negative charge up here and Na+. Now, keep in mind that if this does not show that there's water here, it's assumed. So even if that's not drawn in, you should be okay with that. Did I draw that in earlier? Just making sure. I did not. So that's okay. Be aware of that. Okay. Okay. Here we actually have a carboxylic acid and an amine. So we get the NH2 plus H2O. Okay. Next, we've got an amide. We're going to break this down. So let's start with 1, 2, 3, 4, 5. Boom, boom, boom. There's my carboxylic acid. And here's 1, 2. I get the third one from right here. The OH from the water went over here. When I take into account HCl, that's where the H plus Cl minus comes from. Oh, I'm sorry about that. There we go. Okay, next. This again does not show water. That's okay. You know what to do. We're going to end up with the carboxylic acid plus NH. Boom, boom. We have another H there. Because of the fact that this is in base, it's going to remove this hydrogen, give you negative charge, along with Na+. So you might just say, well, you showed me water in the last time, but you're not showing it to me this time. I'm not showing it to you because I'm also not showing it to you where it's going into the reaction or coming out. Again, it's assumed, and that's fine. You can show it, you could not show it. It's up to you in this case, okay? Okay. And last one, we have an amide and a base. So we're going to tear it apart to a carboxylic acid plus an amine that goes boom, 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 and then the hydrogen's there. Since we're in base, it removes this hydrogen, get a negative charge, plus Na+. Okay? Thank you very much. I really hope this helps. Let me know, and we'll see if we need to do more of these. Okay, thank you.